Hello, this is Suganya working as Assistant Professor in VIT Chennai. In this session, I would like to state a few points about how to make our code to meet the industry standards. So, this is the focus of my lecture today. And whatever academic institute, so whether it can be a college or an university, they are trying to inculcate lots and lots of programming talents with every individual. But what happens when a student when a student got placed and when he goes for employment in any of the industry, he is finding a huge amount of difference or a lot of difference between the coding style that is being followed in industry and what we are practicing in an academic institute. So this gap has to be reduced in these days because so many industry advancements have come, and let's see in our lecture how to reduce that gap by means of simple justifications. So this is what is the situation that prevails in most of the cases. So a student enters into a software company with lots and lots of excitement, and he has a great enthusiasm to get the works done, and up to that point of time he might be he would think that he is an excellent programmer, having excelled in at least any one of the programming platform, and he would have got a love and passion in programming. But when he enters into this industry, all of a sudden he gets into a mess, and finally at the end of the project, so this is what is happening. But this is not as expected in all the cases, but almost in 80% of the cases this is what happens. So let's see how to avoid this, and this is going to be the agenda of my session today. So we'll see how a good code should look like and how it should not be, and we'll focus our viewpoint about different coding styles that we can follow from from the basic itself, and we'll see the importance of documentation, which of course is the most important part of the industry, and let us try to touch some object oriented concept with respect to this category. And this is a pie chart given by that has come out of a discussion that happened in a software engineering institute, where so many researchers and software developers, testers, everyone has come for a discussion. So when a question has been posted like what everyone is expecting out of a good code, this is what is the result. See, the major part of the requirement is for the readability. So everyone wants the code to be readable. So everyone may wonder, why is it called as readable? So do you think whatever the code we are writing is not readable? Yes, of course it is readable. But there exists a lot of difference in this meaning. Let's see in our discussion how it should be. And the second major category given by the developers and everyone is the code has to be well designed. So as you know well, any software project will go through different phases of development in the industry. Start from requirement analysis, then it goes to the design phase, then it goes to coding phase, followed by implementation, and finally one important phase is there which we call it as maintenance. So even if a software goes well in all the first 4 stages, the 5th stage is very, very important, because that is where the actual success of a project lies. So obviously it's not that a project which is coming out of a software industry is going to be used for 1 week or 1 month of time. So this is going to be used throughout its lifetime. It could be 1 year, 2 years, or it may go even for 100 years. We don't know. So in order to adapt, if you want your software to get adapted to all kind of situation, so we need to have this we need to design well your project. Your project should be well designed. See, the correctness comes only in the third part. Why? Because when the readability and the design is proper, the correctness will obviously come. Other things like robustness, efficiency, flexibility, documentation, it should be open for the programmer. It should be referenceable. Revision control is there. Availability should be there. And usability, and it should be benchmarked with some other standards. So all these occupy only a few positions. Means like everything will automatically get done when the code becomes readable and when it is in well designed format. Now in this session, let's see how to make a code to be readable. Who's going to read your code? So obviously it's you that you are reading your code again and again, but it's not only you. So many other programmers will try to have a look into your code because a project is nothing but teamwork. So you are only a part of the team, and whoever is working on the same project or in different project is going to have a look. So testers obviously means like your code is going to be reviewed using code reviews. It is going to be tested when it goes for integration testing by other people, and specifically we have testers in the industry to say whether your code works according to the requirement. And these are human beings who are going to read your code again and again, and everyone knows that the industry is not stable. Today you may be the part of one industry and you may want to switch yourself to other industry for some reasons or other. So wherever you go, whatever the code you have produced must be continued by some other people. So the other things, the basic software which is going to read your code is nothing but the compilers. Since compilers are nothing but the software which will react only based on the instruction given by the human being, you have to make the compiler easily understand your code. That is more important. So good code is nothing but a human readable code. This is obviously what is required. So from Christopher Dickens' point of view, so this is what a good code means. So if you look at everything is what we expect. A good code reflects the problem it solves. So for whatever problem you are writing, so it should solve. So that is the basic criteria. Obviously everyone will do it. So it should be easily understood by programmers without experience in your language. Means like the flow should automatically represent the algorithm. This is most important because at this point of time, C might be the language that has been used. The next point of time, the programming platform might have been changed to some other language like PHP. The next day it would have got changed to, we don't know, some X or Y. So what happens, whatever be the programming language, your algorithm should be same, and always your program should follow some sort of algorithmic issue. Your good code is generally short. This is most important. It doesn't require much thinking to understand. Means you have to reduce complexity in your coding. So it has a very little coupling and it should be cohesive. These two concepts we'll see at the last as an object-oriented thing because these two are the most important requirement. Good code documents. So documentation is very, very important. Otherwise, so just think of whether we will buy a product without a manual. Without a manual, the product is of no use. Okay, so we are getting a product, and in order to apply it, in order to learn its work nature, always will be in need of a work manual. Similarly, every software has to be provided with a work manual through which only the buyer will be able to, or the clients will be able to understand what it is going to do. This last point is very important. Good code makes just as much sense to you 1 year from now as it does now. Okay? Even after years, whatever code you are writing should do the expected things at every point of time. So this is what good code means to you, and how to make a good code. So all we are good in programming, but basically how to make your code good. So these are the 4 key points which we should observe. First thing is you can create by creating a proper structure. Structurally, when a person looks at your code, they should feel happy. Okay? Means like when the second thing is by using standard conventions. Okay? By giving variable names and all, no? So proper conventions has to be used. Third one is using proper documentation. It's not that the entire product alone has to be given a software manual, but every program that we are writing inside the software has to be with the proper documentation. And the last important thing is by placing the code in proper scope, otherwise it may lead to disastrous results. And let's see some of the few key points of how to make the structure and all. First important thing is use readable or consistent spacing. See, here in this code we have placed, this is an instruction. This is an instruction. We have placed the instruction on the same line as the for loop. Logically this is correct and this will work properly. But what happens? So when you look at this code, most of the programmer would get confused, and it may not be a confusion, but there is a chance to leave that instruction as such while they are trying for code review. So instead, a good code will always look like this. Means like you have to write only one statement per line. Then just observe this code for a minute and then just think of what's wrong with this. See, as per this statement, this else belongs to this if. Okay, but what happens? Actually, it is not written like so. Actually, this else has to be the part of if. So, if you want to make this to happen, the code has to be modified. How should it get modified? We have to include some curly brace like this. Now what happens? This else is going to be the part of this if statement. So this is what? This is what we'll be trying to say using this example. And wherever possible, we have to use if-else statements. See, this is also a good code. This will also work logically, but what happens is like the if-else ladder has to be used properly when there requires a multiple condition checking. So this if will be checked. This if will be checked when this else statement, that is this if will be checked when this condition fails. So how can we modify this? So instead of this else followed by an if statement, we can convert it into a else if statement, which makes a, so you may wonder why this has to happen if a program works logically. It's not like so. So if you want to include this set of statement within this else, you need to include a curly brace, which obviously increase the lines of code, and hence it is. So this is not the way to proceed, and this is how a good code should look like. And wherever possible, we have to include blank lines. Why? Because when the program goes to compiler, automatically it strips out all the blank spaces and white spaces. So, and hence it won't increase the size of your module. But for readability, so we have to have a differentiation between the declaration section and the execution section. Here in execution section, we need to segregate the input-output parts, the conditional parts, and the iterative statement. So everything has to be placed segregatedly. See, look at this. So this is a comment line, and after this comment line, we have given a blank name in order to distinguish, followed by the declaration. After declaration, we have left out a free space, and this is how a program should look like. and it increases the readability obviously if you have a look into it. So while using expressions, you need to be a little bit careful, and you may understand whatever be the complex situation as a efficient programmer. But always we have to have our viewpoint from a novice programmer, and everyone who's looking at your code might not get confused. See, what happens here is like, if you understand the meaning of this statement, it is just doing the same functionality as this. So instead of checking whether j is less than n and n is less than k, so the same statement has been narrated in a different sense, which makes the condition somewhat pity. And always, so how can we do? So we have to this is a moderately bad code, means parenthesis is not being used here. So every condition has to be parenthesized properly, and this is what is expected, and this is how a good code should look like. And again, this is one more normal mistake what we used to do normally. While C is equal to getChar not equal to end of. So we may think that a function will get evaluated first according to the precedence of expressions, and obviously it will happen. But basically, when it depends on the compiler in which your statement is getting executed. So if it is a right to left evaluation, then there might be some problem. So whatever code we are writing, so we have to properly parenthesize it. So means like what? Here the C is equal to getChar has to be embedded within a parenthesis. And this is how it should look like. And this kind of code, even if it is logically correct, might make your move to a confused state, and it has to be properly done like this. So this is called aligning of parallel structures. So if you have different statements which follows the same structure, you can do like this. And this kind of statement, see, this is doing the same functionality as this, but the difference is like this increases readability. So this code increases readability, but this code doesn't look like so. So this kind of complex natures we have to avoid, and that is how it should be. So coming to the second part, like by providing conventions, standard naming conventions. So always we have to use descriptive names which will represent the value which is going to be stored onto a variable. So normally when we start programming, we used to declare variables like int a, b, int num1, num2. It should not be like so. Even if you think that giving a lengthier name will consume much amount of time, it's a good practice to start from now onwards, because so if the project's length is of 1000 lines of code or 2000 lines of code, it will be very tedious if you use A, B, C and all. So this is how it should look like. And for local variables, like now for array indexes and all, I and j if you use, then it why as a standard convention it means like if you are using it for array indices. And P and Q is a use for pointers. And there are naming conventions that is being followed in each and every programming language. If you take C programming language, so when you are trying to declare a global variable, it needs to be in all capital letters. Obviously, in most of the programming languages, it looks like so. And that if you take the Java as your programming style, every class name has to follow. In every class name should start with a capital letter for every syllable. And if you take method name or a variable name, it should follow camel case, means like the first character has to be a small letter followed by all capital letters in subsequent syllable. So based on the style that is being used in each and every programming language, you should make your adjustments. And this is the third one, giving documentation, so you should provide sufficient documentation. And this is how you can add a comment. So every programming language comes with a built-in comment support. So you can include comment for each and every line you can include, and for every function you have to write what the function is going to do, including what are the parameters it takes as input, what are the return statements it is trying to give as output as a multi-line comment. So if you look at this code, this is the comment line we have given. So it properly says that this is a function which is going to read a circle's radius from the user input called stdin and compute and write its out diameter and circumference to std out. So the function of every module can be understood by comments. So in my part of my lecture, I will be trying to cover these two concepts: the use of these coding practices in testing phase and the applicability of these coding practices in object-oriented concepts, like how to improve cohesion and how cohesion and coupling comes in practice in object-oriented programming lecture. Thank you. Every module can be understood by comments. So in my part of my lecture, I will be trying to cover these two concepts: the use of these coding practices in testing phase and the applicability of these coding practices in object-oriented concepts, like how to improve cohesion and how cohesion and coupling comes in practice in object-oriented programming lecture.